Hello everybody, welcome back to my channel. So yesterday I posted a video on how to solve stoic questions and how to balance equations. And in that video I talked a little bit about limiting reactants and access reactants. So here's the video that goes deeper into that concept, shows you how to find each of these. So I'll have a link to the other video from yesterday in the description, but let's get started on today's. So let me move this so we can. So let's do some definitions. So a limiting reactant is the reactant that runs out first. So this stops the reaction. And it determines how much of product is actually made. So if we have 4.0 grams of Na and 5.6 grams of Fe, we have less grams of Na, and therefore Na is our limiting reactant. It is going to be the first to run out. And then our access reactant is the reactant that is left over after the limited reactant runs out. And instead of writing limiting reactant, I just put Lr. And so back to our equation, our numbers. When we had 4.09 grams of Na and 5.67 grams of Fe, we took our 5.6, or we knew that our Na was our limiting reactant, and we subtracted 5.67 minus 4.09, and we got 1.58 grams. So this tells us that after our Na runs out, our 4.09 grams of Na runs out, we will still be left with 1.5 grams of Fe. That's going to remain. And so that's our access reactant, the Fe. And then we have our types of yield. So theoretical yield is how much product a reaction should create mathematically. This is how much we should create. Then our actual yield is how much reaction actually happens. So when you think about it, when you're baking, you're mixing your flour and your eggs and your milk or whatever, everything into a bowl, and then you pour that into your pan. Does every little bit of flour get into your pan? Does every little bit? No, you're going to have some leftovers in that bowl that you don't end up putting in the pan. So therefore, your theoretical yield is not going to be the same as your actual yield, because the actual yield will include the stuff still left in the bowl, and the theoretical yield would not. Sorry, opposite. The theoretical yield would include the stuff left in the bowl, and the actual yield would not. So let me say that again because I messed up. So the theoretical yield would include the stuff that was left in the bowl, because theoretically you would have transferred everything. But our actual yield says no, that's not exactly what happens, and so that number is going to be less than your theoretical yield. And then our percent yield is just your actual yield divided by your theoretical yield multiplied by 100, so we can get a nice percent. So how do we find our limiting reactant? So the first step, or the first thing we're going to do, is we're going to convert both reactants to moles. So in our example here, we had Na and Fe, and these were both in grams, and they both have to be in grams for us to find our limiting reactant, because if they weren't in grams, it'd be in moles, and moles doesn't show us that. We need to convert it to grams. So that's our first thing. So anyway, so now we convert both of them to moles. Then we divide by their coefficients, so that way we know how many moles of it we have. Then we stoic both products, or both to their products. We choose a smaller number. And then our fourth step is to stoic the first reactant into another, and then we compare the two. So yeah, let me give you guys an example. So we have we have a question. You combine 50 grams of nitrogen N2 with 2.5 grams of hydrogen. How much access reactant remains after the reaction? If 10 grams of NH3 was collected, what was the percent yield? So they're asking a lot from this question, so we're going to go step by step. The first thing we do is that they give us an equation, but it's not balanced. So we have to balance the equation. and therefore our equation's balanced. If you don't know how to balance an equation, go check out my other video. But we're not going to go over that in this video. We just balanced the equation. Now I changed the background to white so you can easily see my math. But the first thing we're going to do is we converted the N2 to moles. So we took our 50 grams of N2 and we divided it by N2's molar mass. So nitrogen's molar mass is 14.01, but we have two. We have N2. So we have two nitrogens. So it's 28.02 grams per mole. And that gets you 1.784. Now if we're going to look right here, N2, we have no coefficient, so there's one N2. Oh. There is one, oh my god, 1 second. There is only one N2, so we divide by 1 and we get our number. Then here, we do the same thing but for hydrogen. So we have 2.5 grams of H2 times, once again, molar mass of hydrogen is 1.008, but we have two hydrogens. So that's going to be 2.016. And when we do that, we get 1.24. However, hydrogen has 3 as a coefficient of 3 in front of it. So we divide by 3, we get 0.41. So when we take 0.41 and we have 1.78, which one's greater? 1.78. So once we use up all our hydrogen, we're still going to have some nitrogen left. And therefore, our hydrogen is our limiting reactant. Okay, let's look right here. And now we took the 2.5 grams of hydrogen. So this is where that came from. We took the molar mass, which is there. And then we used our ratio. Do please mind my handwriting. We took our ratio. We have 1 mole of, we have 3 moles of H2. We have 1 mole of N2. Well, my pen is not working, guys. Okay, we'll just leave it at that. You get what I'm saying? So that's our ratio. And then the molar mass of nitrogen here was 28.02, so here it's going to be 28.02. So we're going to have 11.6 grams of N2 that was used. And this right here is all your stoiching. So if you're still confused on this, go check out the video that I posted yesterday. It's called Balancing and Stoiching Equations. It's also linked down below. But that was there, right there, was just stoiching. That was the simple math. Now we're going to start finding our excess. So we have 50 grams of nitrogen, right? We have our 50 grams of nitrogen. Let me erase that. Let me try again. We have our 50 grams of nitrogen, but 11.6 of those grams were used. So how many are left? Well, you do 50 minus 11.6 grams of nitrogen. So you get 38.42 grams of nitrogen. That is your excess. So the question's right here. Why did I move back? The question asks how much excess reactant remains. Well, there you go. 38.42 excess remains. Now we have one last question to answer, and that is what was the percent yield? Let's go figure that out. So we're going to go ahead and stoich this equation as well, because we need to figure out, now we need to figure out about NH3 instead of nitrogen. So we take we stoich the equation. Not going to go over this like I said before. Go check out my other video if you don't understand how to stoich. We stoich this. We got 14.1 grams of NH3. This was our theoretical yield. Or sorry, this was our theoretical yield. What was our actual yield then? So let's look back at our formula. So our formula for percent is actual over theoretical. So let's go back. It's actual over theoretical. So our theoretical yield is at the bottom. Our actual's right here. And we multiply it by 100, so we get 70.9%. 70.9% is your percent yield. And there we go. We answered the final part of this question. So this question took quite a few steps. Let's go over it. So we first balanced our equation. So if we had an equation wasn't balanced, we balanced the equation. Then we stored the equation, we found the number of moles, and then we stored the second equation, we found the number of moles. So hence we found the moles of N2 and H2, and this helped us find our limited reactant, which then helped us find our excess reactant because we stored it, then we subtracted it from our original amount. And then finally, we went ahead and did our percent yield. So I hope that this video helped you out. It is really confusing at first, and the only way to get better at it is to do practice. So go find some worksheets online or just rewatch another video or something, but really just try to remember how to do this, and practice is the best way to do that.